OFDM uses 48 discrete channels, narrow band channels, to transmit 48 discrete signals carrying data. So I've got 48 data paths all communicating simultaneously, and if some of them are being wiped out due to interference, it's okay. I'll detect that interference, the data loss, I'll retransmit that data on different channels, and I'll still get a great deal of data transmitted from sender to receiver. And again, this is the technology that allows us to get above 11 megabits per second, all the way up to 54 megabits per second by standard, and in some proprietary implementations, over 100 megabits per second. These radio frequency technologies operate between layer 2 and layer 1 in the OSI model. As we see in the diagram, the 802 specs live at layer 2 a little bit and layer 1 a little bit, so it's approximately in between these two. We also recognize that we have authentication technologies and encryption technologies that get incorporated into the wireless arena, and again, these all spawn out of layer 2 in the OSI model. So we'll be looking at WEP, we'll be looking at WPA, Wi-Fi Protected Access, and WPA2, Wi-Fi Protected Access version 2. Remember, WEP was introduced in 802.11, riddled with flaws. There's vulnerability upon vulnerability. WPA is the replacement for WEP, and because it uses the same encryption algorithm, its performance hit is about the same as that as WEP. And therefore it's compatible with all the old original 802.11 gear. It uses the same encryption algorithm, RC4, a symmetric key stream cipher, and does not require any more horsepower to do the encryption and decryption than the original WEP required. Now WPA2 is the eventual only security standard for wireless. They will eventually obsolete WEP and WPA, and everyone will need to be running on WPA2. The difference between WPA and WPA2 is the addition or the change from RC4 used by TKIP as the encryption protocol to using the Advanced Encryption Standard, AES. AES requires a great deal more computational horsepower to do the encryption and decryption. And if we tried to run AES on the old original 802.11 gear, it wasn't strong enough to handle the encryption and decryption in a timely fashion. So what this says is you'll eventually need to throw away all your old original 802.11 gear, and you'll have to buy new gear that will support the WPA2 with the Advanced Encryption Standard.